Good morning, everybody. So, before I start, is there anyone here who has seen my talk last year at SATURN? There is one. Okay. I'm just giving you a heads up. There will be an overlap with that talk. But the new stuff is at the end. So, Agile architecture road mapping. This is actually almost a continuation of the last talk yesterday by Alejandro and Andres in the room next door, who gave a very nice case study of a road mapping exercise based on architecture, using methods very similar to what I'm going to discuss. So first of all, let me introduce myself. I work for CGI, and my main responsibility there is to review bids and projects. So I'm an architect, and I try every year, at least on one project, to also fulfill the role of an architect. But my main responsibility is actually to look at other people's architectures. And that's a very nice job, because I see so many different solutions passing by. I see so many people working on those solutions. Very interesting in all kinds of industry sectors, in government, etc. And actually, the work that I will be discussing today, the RCDA approach, is almost a side effect of that work, because I started reviewing bids and projects systematically about 10 years ago, and of course, after a while, when you're doing that, you start to see patterns. You see some stuff that always goes right, and you see some stuff that always goes wrong. And so I started to write down the things that went right. And that, in the end, resulted in a different way of looking at architecture, especially in the context that we were applying architecture practices. So that's the second bullet, is the side effect of the first one. After a while, I also started to write some papers about that and publish about it, even got a PhD out of it. And that's what the second half of this slide is about. And at the bottom, you see some of my hobbies. So, the big question that some of us had about 10 years ago, especially when Agile development became mainstream, was, do we still need architecture? And it took us a while to answer that question. Of course, we knew that, yes, we still need architecture. We are architects, after all. But maybe we were a little bit biased there. So what is the real objective evidence that we still need architecture? And I think by now the discussion is sort of settling down that, yes, we need some kind of upfront thinking, maybe not as much as we thought 10 years ago, but we need some kind of design, and the design thinking approaches that we are seeing emerge right now sort of remind us of the ideas that we had when we started thinking about software architecture in the first place. Here is some interesting research done by one of my fellow Dutchmen, Raymond Slot. His PhD thesis, he has done some systematic analysis of almost 50 software projects, varying in technology, in size, etc. And he has basically asked these projects two sets of questions. The first set of questions was, what type of architecture practices did you do? Was there an architect present in your project? When did he start? When did he finish his work? Was he present during the calculation of the budget, or the estimation of the size of the project, etc.? And was there documentation? And the second set of questions that he asked was, how successful was the project? Was there budget overrun? How close was the estimate to the final measured result? How good was the fit of the deliverable of the project? And then he started to do some statistics, and he found some very interesting and quite strong correlations between the application of architecture practices and the success of projects. So I saw some of you already taking pictures of this slide, because you are going to use this slide in your company. So of course, you have to be a little bit careful here because correlation is not the same as causation, right? But still, this is pretty convincing evidence that at least we should have a look at architecture and not just dismiss it offhandedly because somebody says that architecture is old-fashioned and no longer needed in software development. So just to highlight a few, the budget predictability is, the standard deviation in the budget for those budget compared to the real spending. For those projects that used architecture practices was 13, and for those that didn't, 32 on average, right? So that's a correlation, and it suggests a 2 to 3 times better budget predictability for those projects that did architecture. It's specifically correlated, by the way, and you can read these details in the thesis. It's specifically correlated with 2 things: the presence of an architect during budget calculation, and the presence of a documented architecture during budget calculation. Those are the 2 practices that are specifically correlated with this budget predictability. And so there are similar background details on all of those. But just to give an example of how correlation and causation are not the same thing, customer satisfaction, of course, is very important always. On a 10-point scale, so we're looking at 10 to 20% more satisfied customers on those projects that applied architecture practices. The specific practice that this was correlated with is matching the architect's seniority with the complexity of the solution. So matching this architect's seniority with the complexity of solution is correlated with more satisfied customers. It does not mean that the better matched architect automatically makes the customer more satisfied. It may be that, for example, those projects just had better project managers, and they were better able to both satisfy the customer, keep them happy, and also better able to get the right staff for that project, right? So that correlation, that causation may be completely different from what you think at first sight. But still, as I said, it's worth keeping this in mind, and it can be pretty convincing. So the title of this session is Agile Architecture Road Mapping. And it is basically an extension of the ideas that we have been developing about risk and cost-driven architecture. So I will first need to go through the ideas behind that with you to hopefully in the last 45 or 30 minutes of this session to focus on the road mapping part. So these are 5 principles that we sort of focused in on or sort of emerged from the work that we have been doing to trying to unify the architecture mindset with the agile mindset. And we had to make some detours for that, which I will also discuss. But this is what we ended up on. The first one is that decisions are your main deliverable for an architect working in an agile context. And that's a bit of a change compared to what we used to say, which was that, often documentation, architecture documentation was considered our prime deliverable, or the models that we made were considered our prime deliverable. That doesn't fit so well with working in an agile context because of granularity, for example, but also because of the background of what we are doing the architecture for in the first place, which is the third principle: economic impact determine your focus. The second principle: keep a backlog of architectural concerns. That's basically how you organize your work. Keeping a backlog, of course, being in line with agile practices, making it easier to deal with change. That's what backlogs tend to do. The third one, let economic impact determine your focus. That is actually related to the name of the approach, risk and cost-driven architecture, which means risk and cost are economic factors that are important, and that sort of justify the fact that why are you doing some upfront design or thinking? Well, because not doing it first of all, is risky, and second, gives you less control over the cost, maybe in the end. But then, of course, you have to be careful with that and keep it small. And how small? Well, using just enough anticipation. Now, of course, we have seen so many of these just enough mantras, and nobody can ever tell us, well, how do you calculate what is just enough? But I've seen this poem about toast. I don't know. I think I left out a slide about it, but there's this poem about toast how do you know how long to toast? Well, you toast it until it's black, and then you subtract 20 seconds. Right? So, but maybe in this case we can come up with some more useful guidelines. So the first principle, what is your main deliverable as an architect? Well, if we go into organizations and we look at the way that they do architecture, this is, at least in Holland, but I've been told also in other countries, this is becoming a very common picture. Architecture has sort of been established in most organizations that take IT seriously, and they have an architecture department, and that architecture department has some responsibility over the conceptual integrity of the way that they do IT and the way that the IT and the business are aligned with each other. Sometimes it's called enterprise architecture. And then there's the solution delivery. And in most organizations that I have seen, there is some governance process that makes sure that the solution delivery starts up with some form of architecture guidance, sometimes called the project start architecture or something like that. And then the team goes its way, and then there's usually some checkpoints where there is some review, maybe a critical design review, or maybe some compliance review or whatever. Now, this model of doing architecture does not fit very well with the Agile mindset. So this original architecture guidance is usually called BUFD by the Agilistas, big upfront design or big design upfront, and they don't like it. It's a swear word in their world, and this is mind your own business, right? Because what are you doing checking up on me? The best architectures, says our guru, the best architectures emerge from self-organizing teams. So you are not part of our self-organizing team, so what can you possibly add to that best architecture that has already emerged? So this doesn't fit very well. So we need a new paradigm for architecture involvement in Agile delivery teams. So in that paradigm, decisions are your main deliverable. So it's not architecture guidance in the form of a big upfront design, but it's actually architecture more as a continuous process, a continuous, and maybe calling it guidance is not the right word, but somebody being responsible for taking care of the biggest risk and cost impacting decisions. And that becomes the role of the architect, and maybe you don't call it that, maybe you give another name for it. Doesn't really matter. So what is the advantage of focusing on architectural decisions, of looking at architecture as a set of decisions? Well, first of all, it makes it much easier to convey change. And of course, dealing with change is very important in the Agile context. Imagine having a war room where you're doing your work as a delivery team, and you have the architecture printed out on the wallpaper. Actually, that's a very good practice for these kind of situations, especially if you put a pen next to the architecture models, because that will invite people to actually make corrections in it and make comments on it. But suppose that there's a new version of the architecture, and the architect comes in with some rolls of wallpaper under his arm and starts plastering over the previous ones, and then leaves the exercise of finding the differences to the team. That's not a very user-friendly way of conveying change. Whereas if you just tell them, well, we had a meeting about such and such a concern last week, and based on such and such arguments, we decided that we're not going to use this object relationship modeling library anymore, but we're actually going to go with a different strategy here. And these are, by the way, the consequences for the team. This is the work that now has to be done to enable that. That's much more user-friendly or developer-friendly than just giving them the new model. So conveying change, conveying the implications, the rationale, and also the options that were rejected is part of that. It also makes it easier to trace the architecture back to the original requirements or the business drivers that led to this architecture, because the decisions are very often the vehicle that is used to convert such a business driver or a stakeholder need into a part of the architecture. So, also, this fits in with the way that we're looking at doing work in the Agile world. The traditional way of looking at software development is as something that you build and then in a big bang you deploy it. And this is one of the big changes of the Agile world, where actually people realize that these big bang scenarios almost never happened, but there's always already something there, and actually you need to think about development as a continuous stream of improvements of a particular piece of software or IT solution. In the same way, you can look at Agile architecture as making that same kind of change, where instead of a big upfront design, we're looking at architecture as a continuous stream of architectural decisions about an existing architecture. And this picture will actually be in one of the next slides, where I will explain how we have organized this process of the continuous stream of architectural decisions. It's actually using a backlog of architectural concerns. So basically, if you reduce the work of the architect to its bare bones, then this is what's left. The architect comes into his office in the morning, thinks, what problems should I work on today? For the most important problem, he thinks of, okay, what are my options? And then he'll pick one, or she. So that is the absolute minimum to which you can reduce the work of an architect. And this you can convert to what we call the architecting microcycle. And we have some more fancy words in there. So identify and prioritize architecture concerns instead of what problems should I work on. Research possible solutions, and then decide the best fitting solution. Now, you will notice that this is the same cycle that everyone who has a job where he has to make decisions uses, right? Only he doesn't use the word architectural in there. So yes, that's it. That's true. It's just architecture is in a way, a decision-making discipline. So let's treat it that way. And then you can actually add some of the products that you are making in that workflow also. Like the result of the identifying and prioritizing architectural concern is your backlog of architectural concerns. And this is something quite different from a product backlog, by the way. But we're using the same mechanism because backlogs make it easier to deal with change. Why is that? Well, because the traditional way of actually thinking, okay, this piece of work, let's plan to do that in this month, and that piece of work, let's plan to do that in that month, actually makes it a lot more work to shuffle things around. And the backlog is just a way of saying, I don't know yet when this is going to be, but I do know what is more important and what I should focus on first. Then that backlog of architectural concerns is input to the research possible solutions activity, where you just take the top 2 or 3 concerns and see how you can address them by making architectural decisions. You decide on the best fitting solution, and here is your primary deliverable, your stack of architectural decisions that comes out, and hopefully more or less as a continuous process. Now sometimes that doesn't work that way because some architectural decisions will take you you know, 1 or 2 months to decide on. Maybe you do a lot of work, you build a prototype just to make sure that you're making the right decisions, etc. But still, it's a lot more, let's say, a finer level of granularity than your big architecture document that everybody is waiting for you to deliver at the end of the elaboration phase. So I say elaboration phase, that's a RUP term. Does anyone still use RUP? No, but you know what I mean, right? It's the architecture milestone. Okay, so the next question, of course, is I talk about prioritizing this backlog. And here is where, you know, how do you prioritize that? That is where the name of the approach comes from. Because we are, of course, we want to address the concerns first that have the most architectural significance. How do we decide what has the most architectural significance? And that's the third principle. Economic impact decides that. Those architectural concerns that have the most economic impact are sort of automatically the ones with the most architectural significance. That is not always true, but it is almost always true, and it is such a close, you know, such a good approximation that doing this you can hardly ever go wrong. So here are 2 definitions of architecture, or what an architecture is about. This is the official world standard definition by the ISO and the IEEE. Fundamental concepts or properties of a system in its environment, embodied in its elements, relationships, and in the principles of its design and evolution. This is the 2011 version. Those of you who still have the 2000 version in their mind, you need to change it. But this is obviously a committee-defined definition. Martin Fowler has a much more elegant way of saying it. It's about the important stuff, whatever that is. And if you can get a hold of this excellent paper, it's in IEEE software. It's from 2005, I think, and you should get it. It's a very nice read. But important, you know, is not an objective. It's a subjective concept. So what we, after a while, what we figured out was, and this was all in the context of how we were doing architecture at CGI, or Logica, as it was called at the time. What's important, you can actually equate that to the impact in terms of risk and cost. Now, some of you I know will already are now planning to ask the question at the end of the session, how about value? Isn't value also important? Yeah, of course it is. But there's basically 2 reasons why we call it risk and cost-driven architecture. Because in our experience, making the approximation of determining architectural significance by risk and cost already has the value in it. Because if a concern represents a lot of value, then it also, probably has a high risk of not fulfilling that value. So you should avoid double counting. And the second reason why we are omitting value here is that if we have seen architects place too much focus on value, on adding value. And these architects are very quickly, they are becoming unpopular because they are accused of doing gold plating. Oh, we can add some value here. Oh, we can make it very nice here. And that's usually not what the stakeholders that we are dealing with want. They just want you to make sure that what they have specified is delivered, or what they say that they need is delivered. And usually they are more happy with something that minimally fulfills the requirements, but on time and on budget, than they are with something much more fancy that is then delaying the project. And there's also a third reason for saying risk and cost and not value, and that's this sometimes leads to very nice discussions with people. So. Right, so architecture as a risk and cost management discipline. We are looking at managing risk and cost as architecture's primary business goal. And they are the prioritizing factors to determine what you should focus your attention on. That also means that architects should learn a little bit. They should be experts, or at least know quite a bit about costing and risk mitigation. And so and this also fits very nicely with the table that I started this presentation with from the PhD thesis of Raymond Slot, because he actually shows us that there is a correlation between applying architecture practices and reducing uncertainty in the visibility and troubled projects, and also predicting the cost and less budget overrun. So that ties in very nicely. So this is why we have called this approach risk and cost-driven architecture. It's not because we think that risk and cost should be the criteria by which you make all your architectural decisions. No, of course not. The criteria that you use to make your architectural decisions are maybe related to risk and cost, but they are usually more related to your non-functional requirements, your quality attributes, etc. No, it means that you use risk and cost to prioritize the work that you're doing. And what we have noticed is that this way of looking at architecture works both in an agile context, but also in more traditional engagements. It's also important there. It's very scalable. We are in situations where we have to make big architectures in 3 weeks. This, for example, often happens during a sales phase of a project, where we get a request for proposal or an invitation to tender. We have to design a solution that fulfills the requirements of the customers, and we have only a few weeks to do that because that's what the deadline for submitting the offer. That means that you have to be able to time box your architecting work. So in that case, it's very important that you start with those architectural concerns that have the most impact on the economic factors of that solution. But it also works on projects that are running for months, etc. What it also implies is that our architects are, because they have to dig into the concepts of risk and cost and think of the risk and cost impact of their architectural decisions, that they also become better at communicating about those decisions with business stakeholders, because the business stakeholders are much better at understanding these economic terms than they are at understanding things like close cohesion and loose coupling, right? I've already said this. Right. So the fourth principle here, keep it small. Because we do know that architecture, we still need architecture, but there is a limit to how much architecture we need, and we're basically saying that architecture is potentially harmful. Every architectural decision you make will constrain everybody downstream from you, or at least it should constrain them, because they should comply with that decision. If they don't, it's better not to make the decision at all, right? So every decision you make sort of hurts everybody downstream from you in constraining their design freedom, etc. So you should be very careful. And this is actually a principle that some architects do not like at all, because there are many organizations in which the bigger the thing you make, the more important you are. Right? And if we say that architecture should be minimal, that means that the thing that you are making is not as big and maybe you're not as important. It's not true, but that may be the perception. One with very many changes occurring, either in the technology or in the business part. Then thinking too much ahead doesn't make that much sense, because what you have figured out may lose its meaning as these changes occur. So the formula that is actually in his paper, there's a slide with references at the end of this, and you can read this. But it actually gives you an amount of hours. So you input the parameters for business criticality, size, and volatility. You estimate those, and then it tells you, okay, in this case, it is best to spend 15% on upfront design. So that's an interesting outcome. So the final principle here is use just enough anticipation. So another one of those just enough X things, principles. How do we determine what just enough is? Well, there's an interesting metaphor which I have first seen in the Scaled Agile framework, but I think it's older than that. But it's the metaphor of the runway, the architecture runway. So basically what the metaphor says is that you can compare architecture to a runway, and all the features that you have to build, all the stories and epics that you have to build, are the planes that have to be able to land on that runway. And if your architecture runway is a grass strip, and the feature that you have to build is a Boeing 747, then it will crash. And that's exactly what happened if your architecture is not good enough, not strong enough to build certain features that are coming. So the secret of just enough anticipation is to know what kind of planes are coming, and to build your runway, just long enough and just strong enough to be able to land those planes. So you might be starting out with a project, perfectly sensibly, with a minimal type of architecture, which you can compare to a grass strip of, I don't know, maybe 2 kilometers long. And that's actually quite long for a grass strip. But and as long as all the planes that you have to land there are gliders and small propeller planes, that's fine. They can land on that. But if you know that 6 months from now, actually we will have to be able to land a private jet, then you have to start pouring concrete pretty quickly, right? And you have to know how much time you need to pour that concrete. How much time do we need to actually strengthen our architecture to be able to deal with that feature that's coming. And sometimes you don't have the time. We suddenly hear that a week from now there will be a big cargo plane landing. Okay, so what do? This actually happens in the Navy, for example. What they do is they have a temporary runway that they can just roll out, and then the cargo plane can land, and they can take it away again. Of course, the same thing happens in software architecture, where we sometimes make a temporary, provision for a big feature, and we always plan then to later on to turn this temporary solution into the permanent solution. And what do we call this phenomenon? Technical debt, exactly. And our only problem is that in this metaphor, that temporary runway is very visible. So people keep being reminded of the fact that, hey, we are dealing with a temporary solution here. Whereas in the software world, very often these temporary constructs are not visible to the end users, and they need some very thorough reminding that this technical debt is still in there, and that we do need to make some time to get the real permanent solution in there. To determine this right amount of anticipation, there's basically 3 tools, and this list comes from a paper by Ipek Oskaya, who we have seen walking around here, and Nanette Brown, I think, John?
Yes.
Yeah, and who else? Was it Philippe?
Maybe Philippe was
Yeah, okay. So basically, they made a very nice analysis of determining the right amount of anticipation. And they said there's basically 3 tools that you need: dependency analysis, technical debt control, and economic trade-off. And we will go into a little bit more detail with those. So this is definitely Philippe's. This is Philippe's coloring scheme for backlog items. Who has seen this before? Okay, it's about 30%. Not bad. This is a fantastic tool to understanding the structure of the things that are in your backlog, and being able to to reason about them and to plan them in your roadmap. What Philippe says is you can divide up your backlog items in two ways. One is between visible and invisible stories. So the visible stories are things that are visible to the end user. The invisible stories have no effect on the end user, no direct effect on the end user, but only indirectly because they affect the visible stories, right? The visible stories can be dependent on the invisible stories. And then he says there's also another way of dividing it up. There's positive value and negative value. And then we have the visible stories with positive value. This is the green ones. New features, added functionality, all the nice stuff for our users. The ones with negative value, also the defects, very visible and need to be getting rid of. And then invisible, on the invisible side, you have the under the hood improvements that have positive value by, for example, enabling more new features or enabling new features to be built more quickly. And then there's the invisible stories with negative value. They are causing trouble. They are causing, while they are not, while these stories are not built, they are causing the trouble. And the trouble, of course, in the technical debt metaphor is the interest that you're paying for the debt that is in the system. Now remember these colors. Technical debt is black. Architecture is yellow. Features are green. And defects are red. So here you see how this works. You all know this picture. You see that the solution backlog items are now colored using this color coding scheme. We have the sprint backlog here, and we have here, of course, the gate that controls what out of the solution backlog that goes into the sprint backlog. And then we have the famous sprint cycle here and the daily stand-up meeting cycle there. Somehow I'm losing my red dot. Never mind. Leading to a solution increment. So how does this fit with the architecting microcycle and the work that we have been, the way of working for the architect we have been discussing? Well, it fits very nicely on top of that. So here we have our own backlog, the backlog of architectural concerns, prioritized by risk and cost impact. Here is the decision-making cycle and our primary deliverable of architectural decisions. And the architectural decisions, of course, they do not go directly into the solution backlog, but there's something that you must do. You must actually translate the impact of the decisions into stories, architecture stories, or whatever you want to call them, epics, depending on which abstraction level you're working at this point in time. By the way, this works both at the epic level and at the more detailed user story level. And that, of course, leads to mostly the yellow blocks in a solution backlog. Zooming out a little bit, this is the complete story. You have your stakeholders. The stakeholders, they produce user features and defects. Well, they're not producing defects, but they want these to be removed. Well, actually, of course, your development team is a stakeholder also, so yes, they are producing the defects. And filling up the visible side of the solution backlog. And then we have the architectural decisions filling up the yellow and the black stuff. And then here, of course, we have the natural tension, what should go into the sprint backlog. And who decides this? Who decides?
Product owner.
Product owner, exactly, yeah. Product owner decides what goes in here. Product owner is not the same as architect, of course. And then we know that I think many of us have dealt with the product owner who has just come out of Agile school and knows that only the green stuff is allowed to make it through this gate, right? So what do we get if we only allow green stuff to come in here? Sorry? More technical debt, yes. I call it the technical debt factory. That's what you get. You automatically, without even, you can almost scientifically prove that if you only allow green stuff to go in there, that your technical debt will increase. If your technical debt increases, the interest that you pay every sprint will increase, and your velocity will automatically go down until your complete project runs into a wall. Here you see, by the way, that this daily stand-up meeting here touches the architecture microcycle. That is not a error in the drawing. That is actually because the two have the same sort of cadence, the same rhythm. And the daily stand-up meeting can be a very important source of architectural concerns, because it's very often the development teams that identify these concerns and that notice these concerns first, and then the architect can actually deal with them if he is in touch with them, and that's what's visualized here. But also there are architectural concerns coming directly from the stakeholders. For example, there may be a user feature here that if we are, and should make sure we are, as architects, we are involved in the intake process for these backlog items, because we know that there are always some user features that nobody notices except us, that they actually have the potential to break the architecture, and that they lead to at least one or two architectural concerns that we should deal with on our backlog. So that's the 5 principles, and this is how we try to get just enough anticipation. Of course, there's a lot more to say about this, and actually we're going to spend the rest of the session to discuss how to bring a little bit of structure to this arrow here, because that's the arrow where the most important decisions are being made as to what actually gets realized and what doesn't. And if that goes wrong, then we end up with a technical debt machine. Any questions or remarks so far? No? Okay. Let's continue. So the architecture road mapping is about architects dealing with the time dimension. And this is another sort of new thing for many of us. Architects, if you consider architecture to be the structure of a software-intensive system, as the original definition all the way back in the 90s was, then the time dimension doesn't really have a place in there. It's something that you design, and that will eventually be there. Everything should be done to create that, but the time dimension is not part of that structure. And as was very nicely demonstrated by Alejandro and Andres in their talk yesterday, actually there is an enormous amount of architectural significance in the decisions that are made in the time dimension. And I think, especially if you look at architecture as a risk and cost management discipline, we cannot afford to ignore the time dimension in our architecture. I have seen a lot of architecture documents, a lot. And what I've noticed very often is that these documents are not always regarded with the same level of respect, let's put it that way. And for example, architecture documents that are almost finished until the project is finished, right? And many people waiting for architectural guidance, waiting for the 1.0 version of the architecture, whereas we know that doesn't really exist, especially if you look at architecture as a continuous stream of design decisions. There isn't such a thing as a 1.0 version. Well, there may be one, but it's not more important than the 2.0 or the 3.0 or whatever. It's all right to baseline these architecture, the status of the architecture, in the sense that you take snapshots and maybe at critical points in a project have some approval process or something in place. But we all know that architecture is not time independent. We are continuously dealing with architectural concerns and addressing them with architectural decisions. And at any point in time, unless the product is in production and there are no problems with it anymore, but until that point in time, there are always remaining architectural concerns. So what we have seen is that this, these guidelines for having architecture documents, maybe a reference architecture that the domain architect should make, you're either waiting for it to be released, or it's already obsolete because it was released 2 weeks ago, but now already the world has changed. I think it's time that the time dimension became a first-class citizen in this architecture documentation. What does this lead to? Of course, risk of development based on revoked architectural decisions and difficulty planning ahead. So how could we realize this? And here I hope that we get a little bit more interactive because this stuff is pretty new. We are experimenting with this, with introducing the time dimension. And I'm really interested in your views and your experience with this. So one of the things that we think may help in introducing the time dimension in the architecture work is to create a special viewpoint for it, which you could call the evolution viewpoint. Now, who here does not know what a viewpoint is? Okay, I will explain. In all the architecture documentation standards, and there's the most famous ones are up here, all of them make use of the concept of views and viewpoints. And what this means is that architecture is not a single model, but actually architecture documentation should show how the concerns of the stakeholders are addressed. And to show how a concern is addressed, you actually have to take the point of view of that stakeholder. Otherwise, you cannot communicate how his concerns are addressed. And taking the point of view of the stakeholder, that is what we do in viewpoints. Here, and these pictures at the bottom here are actually a perfect illustration of this, because they show the architecture of the human body, and they all have to show how a particular concern of that stakeholders is addressed. For example, this shows how the concern of, staying upright and not looking like some creme brulee is on the floor is concerned. And what concern is this? Sorry? Circulatory. Yeah, that's the model. It's a circulatory model. But what concern is addressed by it? What stakeholder concern is addressed by this view?
How the nutrition goes to body structures.
Exactly, how nutrition and energy goes to the body, right. So, and this is the nervous system, so this is the concern, how does the information get through the rest of the body? So, and that's why we have, and Philippe Kruchten once again, unfortunately he's not here this year, but he wrote a seminal paper on views and viewpoints, the 4+1 architecture views, and defined four very common viewpoints that address four very common stakeholder concerns in software development. And that idea is present in all of those standards. So how about looking at time as a specific concern, or evolution of the solution as a specific concern, and creating a special viewpoint for that? That's what we have been working on. And to create that evolution viewpoint, the first thing we have to know is what is going to happen that impacts the cost, risk, and or value of our solution. So we have to know this. We have to identify events with architectural impact that we can predict. Now, of course, the accuracy of that prediction can be good, or it can be not so good. Some of these things that we have, the examples here. Let me first talk you through the examples. So the competitor releases the next generation of their product. That's typically something that they announce. They're going to say in the fourth quarter of 2017, we are going to have this big new fancy product and it has such and such features, right? Now, we know that this is actually going to affect the cost, maybe not. Risk, yeah, and certainly the value of our own product if we do not, at that point in time, match their features or have something similar fancy. So another one, Microsoft Windows XP support is discontinued. We knew this ahead of time, right? This was announced at the time, the 4th, I think April of 2014. The impact type here is risk because vulnerabilities are no longer patched, and it's a security risk, etc. So if we would have known this ahead of time, and we did, then we could plan actually in our architecture roadmap to get rid of Windows XP in our application landscape. So you see, this is not just we are using this this method not just for a single application or a single piece of software that we are architecting. The same approach, and this actually goes for all of our CDA, the same approach works also for landscapes of applications. Also for infrastructure and services we are using it. So all of these principles are not just for software or application architecture. We're using it also for higher levels of architecture, domain architecture, maybe even enterprise architecture. So here is another example. A license contract expires. Well, that has two kinds of impact. In the first place, if we know that the license contract expires, it gives us as architects the freedom or a very good point in time to think whether we want to continue working with this product or whether we actually would like, there's something better on the market right now or maybe even something open source that we can use instead. So it has impact on cost, but maybe if we have to renew that license, we decide not to change it also. So all of these things are things that impact our architecture at a certain point in time, taking that time dimension with us. This may be the most common future event, the project to build system Y finishes. So very, very often, I think almost always, our solution or our product is part of a wider ecosystem of software systems and other systems that it communicates with, and it's that are changing all the time. They all have their own evolution cycles, and if we know the critical moments in those evolution cycles that affect somehow the risk, cost, and value of our own solution, then we can take that into account. So once we have identified these future events, the second thing that we have to identify is backlog items for our solution roadmap. So I have already shown you this, this color coding scheme. And where do we find these backlog items? Well, of course, the green stuff is very easy to find. It's always very, very visible and pushed by all the stakeholders, etc. And also the red stuff is easy to find. You can find it in the defect database. Now, of course, because we are actually trying to do this on the architecture level, we're not that interested in individual defects. We are more interested in very risky defects or defects, groups of defects that are really impacting the cost or value of our solution. We find the yellow backlog items in our own deliverables, the solution blueprint, architectural concerns, maybe a part list, and then finally we have the technical debt. Where do we find that? Well, that's an interesting one. I actually could talk for 90 minutes also about how to identify technical debt. But if we are doing our work correctly and we are keeping a nice backlog of architectural concerns, we expect the technical debt, of course, to be in there. Very often there's a risk list in a product or a project organization that you could also find the technical debt. And I know some organizations that have a very nice technical debt register. Unfortunately, that's very often is also a write-only document, right? People keep track of the technical debt in the system just to be reminded of it, I don't know. But so what is the next step here? Dependency analysis. This is necessary to be able to, to extend the runway in time. We have to know how all of the stories depend on each other. And here you can actually see a number of stories and how they depend on each other. I think we have all learned this in software school. how to make a dependency analysis matrix. It's pretty obvious, but here we have use cases, and here we have architectural structures, architectural stories that these use cases depend on. So for example, to be able to build use case 1, we have to have the session mechanism in place, and we have to have the data persistence in place. Data persistence and session mechanisms are under the hood. They are not visible to the end user. They are architectural constructs, architectural stories. But we cannot build use case 1 until these architectural stories have been made. That's your dependency analysis. These actually give direct value to the end users, but these only give indirect value. Here we have some acceptance tests, and the acceptance tests very often they represent quality attributes, like this can be a performance test or something like that. And we actually need the caching mechanism in place to be able to fulfill this acceptance criteria. Right? And then, putting it all on the visual timeline. And here, everything that we have done before with the first 3 steps comes together. We are reminded, of course, of the color coding scheme in the legend. We have the timeline, and we have put some release numbers on there, but that's not really necessary. But here we have the future events that we have identified in the first step, that we know the impact, the risk, cost, or value of our solution. And here we have the various stories that we have put on our roadmap. And the way that we put the stories on our roadmap, of course, first of all, depends on the dependencies that we have identified in the dependency analysis. So for example, here is the competitor that releases the next generation. We want to have this feature in place before the competitor releases the next generation. That way, we can soften some of the pain of all that new fancy stuff that the competitor will have in their next generation project, at least they say. So this feature we have to have in place. That's why this dependency arrow is there. But we also know that in order to build this nice feature, we first have to create an architectural construct. And this can be anything. This can be maybe having to upgrade to a new version of a layer product, or it can be having to, well, maybe, we can use the example from the dependency matrix. It's a little bit simple, but if this is a performance enhancement, then this might be that caching mechanism that we need to create that performance enhancement. So we cannot, if these arrows are there, we cannot plan this after that. And then finally, the last method that we use to actually determine what is the best order to place these features on our visual timeline is economic analysis. And here is where all our hard work of trying to determine the economic impact of all of these stories and the events pays off, because that will allow us now to make some approximation of the what is economically the best order in which to plan these stories. And then we can calculate rather than fight about. Well, you can still fight about something you calculated, but let me rephrase. You can actually calculate what is the better what makes more economic sense to actually get this thing out there and maybe take on some technical debt that we will repay later, because the interest of repairing it in technical debt later on is less than the damage if we don't have that feature there in time, right? Or no, actually that doesn't make any sense because the interest is so high that the economic damage of the technical debt staying in there is much bigger than what we might gain by actually beating the competitor with this feature. You can actually right now make an educated guess at the difference in value between those two scenarios, rather than just fighting with the product owner, who will always maybe say, no, the feature has to be there, and the architect always saying, no, architecture always comes first, right? So this economic analysis, and in the paper that I just mentioned, I think there's another paper also by Rick Kazman, where he gives very nice examples of how you can do this economic reasoning. I think Actually, he gave a class on Monday where he sort of mentioned that. Did anyone attend that class? Yeah? Did he say something about economic calculation of technical debt reduction? No? Okay. Well, then we have to go to the article to read that. So there we have it. We can now look at various strategies for planning these roadmaps. This is one extreme. It's the value first planning. So in this example, we start with green stuff, of course. And then in the second iteration, maybe we will, we will repair a defect, and maybe we will build one little piece of architecture, etc., etc. But value first. So what we see here is the value and the cost curve that are associated with this. The cost curve more or less is equal to the total, surface area of all of the stories that we are building here. And the value curve, of course, is only the value of the green and the red stuff. Maybe even the red stuff doesn't. Yeah, the red stuff actually decreases the value, so yeah. So what we see here is that in the beginning, the value curve goes up very steeply. But here, it sort of flattens a little bit, actually a lot. And the reason for that is that we are delaying the architectural constructs. So we are now having to spend some time on those here. But also, we have to do some refactoring. And the refactoring, of course, are the black ones. And they are causing interest that has to be paid. And that's why we can put less and less green stuff in here. So this curve actually becomes flatter and flatter. Now, this, of course, is just assuming a particular context. It may not be that way. It's just an example. What can happen, of course, is that at a certain point in time, this all fills up with interest on your technical debt, all with black stuff, and that means that your velocity goes to zero, basically meaning that your solution is completely broken. You have to start anew. This is a very good scenario, of course, in very volatile environments, because every yellow thing that you build, every yellow story that you build, is sort of assuming a particular, context to stay that way. The architecture is hard to change, so if we build architecture, we're assuming that we can still use it a year from now. And if we do that too early, if we build too much architecture too early and everything changes around us, that will just be ballast. So then this curve will look completely differently. The other extreme, architecture first road mapping, is where we start building a big architecture framework. We have one green thing here, maybe it's Hello World. And, but first we have to be absolutely sure that the architecture framework is right before we actually continue building more functionality on it. So what we see here in this scenario is that, first of all, the value curve goes up very, very slowly in the beginning. And the cost curve, of course, goes up almost as fast as in the previous one. So the value curve actually stays beneath the cost curve for a long time. And of course, that's the big risk of this scenario, is that at this point in time, some of your stakeholders will lose faith, say that this is all sunk cost, but let's just pull the plug on this project. And who has this happened to? It happened to me. Yeah, I see a few people honest enough to admit it. So that's bad. Also, the big risk of this is that here the whole world changes and that this framework actually turns out to be no longer the best framework. Maybe the business has changed their mind. But what also happens is that you have built this framework, and here you find out that there is now some very nice, fancy open source framework that will do exactly the stuff that you just spent so many iterations on. Happened to me as well. So those are all risks having to do with, once again, the volatility. If you are building a very complex solution, And of course, we are reminded of Barry Beam's formula here again. We have 3 factors determining whether this is, how much upfront architecting you do. It's size, including complexity, business criticality, and volatility. If you have a very complex solution, this is also better because you can then, before starting to build all the functionality, you can make sure that the complexity is managed and manageable. And then later on you can fly because your architecture framework is absolutely perfect and you don't need to spend any attention on it anymore, and everybody will just create functionality very, very quickly. So we have been experimenting with this, as I said. What we find is typically that if we ask our architects to identify these architecturally significant future events, these are 4 typical types of events that they then come up with. Project and process milestones. So delivery deadlines, approval deadlines, etc. Also, very often deadlines in dependent projects. So, we have to have our stuff done because the other project depends on our system being able to deal with that interface or something like that. That is the most common future event with architectural significance that is identified. Then product version and infrastructure upgrades. And these are usually a little bit softer than the deadlines in the first bullet because you have some leeway in when are we going to upgrade this product, when are we going to put some new hardware in there, etc. But if you leave it in there too long, it automatically becomes technical debt. You don't have to do anything about it. Then there's business changes, and these are often very hard to predict. So these may be changes in service level agreements or KPIs of a particular organization. Mergers and takeovers, they just happen. If you know them, if you have some sense of the timing, you can anticipate them. Otherwise, it's harder. Legislative changes, policy changes, they are probably somewhat easier to predict. Owen yesterday was talking a lot about the banking or the financing world, where this is actually an annual rhythm almost of new legislation coming about that the architecture has to deal with, and they know it way ahead of time. And then finally, and here we get on the edge of what we have to deal with as architects, or maybe it's somebody else's problem, but this may be the changes in availability of resources. But one of my architects actually mentioned that this was a key future event that they had to deal with. They knew that 2 of their key programmers were leaving, for another project 6 months from now, so they needed to have all of that, that module modified before they left. And it's a good example because it actually impacts the cost and the risk of the changes. Before those experts leave, actually making those changes is a lot less risky and probably also less costly than after. Lessons learned. Well, these anticipation documents or evolution viewpoints, as we call them, are never called evolution viewpoints in real life. They exist, but often as what they call a roadmap or a decision support document or a strategy document or whatever, maybe a domain reference architecture. But they exist, but maybe now that we have a concept to discuss them and to reason about them, we can improve the way that they deal with the time dimension. Another lesson learned is that it's absolutely crucial, if you are starting with step 1, identify future architectural significant events, then you absolutely have to talk to your stakeholders because otherwise there's no way for you to find out most of these events. So to summarize, real-life experiences, these are the things that our architects say benefits that they have observed from doing this, from including the time dimension in their architecture work. First of all, and this is reported by many of them, improved stakeholder expectations. So because they are now able to actually reason about the, well, not so much reason about, but communicate about the impact of doing architecture work in the roadmap with stakeholders based on economic arguments, they are much better able to manage the expectations of those stakeholders. Stakeholders that, oops, for example, in this scenario, the stakeholder expectation after release 1.0 of this value curve is actually that it will be going up at the same slope in the future. They don't know about this, and if they do know about it, they very often try to push it backwards, right? The yellow stuff and the black stuff. You know, why do you worry about that? It's working. And so managing the stakeholders' expectations actually will allow you to maybe convince them more easily that actually, you know, it's in the end it's cheaper or less risky if we put some of this architecture work a little bit more forward. So that's the most important contribution or benefit here, and it actually helps also realize a lot of other benefits then. For example, the second one, prioritization of required architectural improvements. And I think we've all had our frustrations in convincing stakeholders that architectural improvements need to be planned, you know, in time before they cause more trouble. Helps architects articulate the business impact of road mapping scenarios and discuss the timing of architectural improvements. And being able to do that based on business impact and business arguments rather than just your gut feeling or having the fight with dogmatic rules like YAGNI, you know, YAGNI means you ain't gonna need it. It's a swear word in the Agile community to indicate that if you are considering doing some yellow user stories, meaning putting some architecture work in there, that it's not 100%, when it's not 100% sure that you need it, then you should not do it. Well, that's all very nice to have a dogma like that, and it's a very nice rule of thumb. Nothing wrong with that, but you cannot use it to decide on what is the best road mapping strategy. You need more information for that, and I think the economic information that we have discussed here, I think is a good basis to discuss it at least with business stakeholders. Okay, that's it. I said I was hoping for some more interaction in the second half, so maybe that will come now. I see already some hands. Yes?
Question. You mentioned two certain scenarios that the value first and another scenario is the architecture first, right?
Yeah.
Which one do you think is best?
Okay.
There are certain ones.
There is, well, actually the third one is always best. Okay, I will repeat the question. So I showed two basic road mapping strategies, value first and architecture first. And the question is, which one do I think is better? This one or that one, or is there a third one that is even better than those two? Well, my answer is the third one is always better. Why? Because these two are extremes. These are based on dogma, right? This is the dogma that you should always do, you always prioritize value over, you know, other concerns. And this one is based also on a dogma that you should always have your perfect architecture before you can even think of actually building functionality on top of it. Both are wrong. They are extremes just used to illustrate here that actually we need a third way, which is economic reasoning to determine what is the best strategy here. And that's more work actually, so that's the bad news. But the good news is I think that your stakeholders will be happier and you too. Yes?
And it's also depends on your project, because sometimes your project is like you build from scratch, and you have to upfront you have to put the architecture infrastructure. You have to build that up too.
Right. Yeah. So it depends very much on your project as well. I'll repeat your comment. Because on some projects you can just start off with a ready-made architecture that maybe you even downloaded from the internet, because all your quality attributes are standard and the ready-made architecture. So that's actually basically here you're downloading your architecture already and you can just start. And in other projects, you have different quality attribute requirements and you actually need to build your own and do some more upfront architecting. Yeah. Yes?
What are you using in your cost and value to get that graph? Because that's where we're struggling, is value and cost measures.
Right. So that's a good question. The question is, what are we using to determine these graphs in terms of cost and value? Well, these graphs are just, let's say, illustrations, right? They're not based on any real calculations. But there are methods out there that you could use to do that. For example, the value curve, it's very hard to calculate the business value of a user story in terms of hard dollars. I would say it's impossible. But if you're interested in approximating it, with the help of stakeholders, look at Rick Kasman's work. His cost-benefit analysis method, CBAM. There's a very nice technical paper on the SEI side about that. That will at least allow you, together with the stakeholders, to approximate the value curve. The cost curve is, of course, a question of good estimating. And there's several methods for that as well. Don't fall into the trap here of using function points. Function points are good to estimate the green backlog items, because the amount of work in the green items is you can measure by functional size. But all of the non-green items, the architectural constructs and the technical debt, they need a different type of estimation because the amount of function points is basically zero for those. Yes?
You mentioned in the beginning the backlog, the architectural backlog and the development backlog, that there is a difference.
Yes.
Can you say more about it?
Yeah. So this picture illustrates that. So here is your architecture backlog. The items on your architecture backlog are architecture concerns. They're basically questions that you have to answer, problems that you have to address as an architect. They are things like what technology should we use to do this, or how can we improve the performance of this part of the functionality. There are questions that need to be answered, basically. And the answers are in the architectural decisions that you make to address them. These are the more traditional stories that have to be realized. And if you confuse them, some people say, well, why not put these backlog items in this solution backlog? Then you're starting to compare apples with pears. And the reason that's bad is because they need to be prioritized in a different way. This needs to be prioritized the architectural concern backlog needs to be prioritized based on economic impact, risk and cost impact mostly. And this can be, should be prioritized based on your preferred road mapping scenario. So that could be value first or architecture first or whatever, but it's a different form of prioritization. And if you prioritize everything the same way, you're not getting the best results. Let's see, the gentleman behind was first. Yeah. No, behind you. Yeah.
Yeah. My question was, are you using this in all of your projects? And secondly, how well does this work with traditional waterfall lifecycle?
Okay, so the question is, there are two questions. First is, are we using this with all of our projects? And the answer is no, not yet. As I said, we are experimenting with this. We have trained, very many architects in this approach. but not all of them have been in the position that they can actually use this. It depends on very much on the kind of engagement that they're in. But the feedback that we've had and the benefits that I've reported are based on the feedback of about 10 architects who have been doing this in practice. And the second question again was?
How well does this work with the waterfall approach?
With a waterfall approach, right. I think you can do very much of this also in the waterfall approach, especially in the early phases, in the design phase of waterfall. You can. You should also look at this, the time dependencies of your architecture. Absolutely, yeah. Okay, Andres.
Just a small clarification. Is there a relationship between the architectural concerns and quality activity scenarios, for example? And a related question is, these quality scenarios play some role along the roadmap, like intermediate goals that constrain the way in which you develop the roadmap?
Absolutely, absolutely. So an architectural concern usually derives from an architectural requirement. It can also derive from something else, from something just happening, such as finding out that some technology doesn't work. That can also raise architectural concerns. And the other types of architectural concerns actually enter the backlog through this route, because the team finds out that the technology doesn't work. But the architectural concerns that you start out with are mostly based on architectural requirements, which are, of course, expressed in scenarios. And these can be quality attribute scenarios if you are talking about a software system. But very often, if the solution is more than just software, it also includes hardware and maybe some organizational aspects, then quality attribute is not always the best language to express the architectural requirements in. But you can still use a scenario. It's just not a quality attribute scenario. I see Alejandro affirming this. Okay. Yep.
Going back to one of the previous questions about the architectural microcycle, is there a partial ordering implied between the architectural concerns and the decisions that follow on from them, and the implementation items that show up in the solution backlog, in the sense of by choosing to do just-in-time architecture, addressing architecture concerns when they're going to be needed, are you not also driven by the feature items that are in the solution backlog and when you need those architectural concerns addressed in order to address the features?
That's a very good question. So the question is, what is the relationship between the just-in-time planning that you're doing here and the time that you address the architectural concerns in this backlog? The simple answer is there isn't one. Because you need to address those concerns, even though you may not immediately do the work coming out of the architectural decision. You need to address the most risky concerns first by making architectural decisions and putting them in your architectural decision log. Because that is the only way to make sure that you're not missing out and searching under the lamplight, as Tom Gilp said. I don't know if you know that reference. Okay, do I have time?
Very quickly.
Okay. Okay, I'll end with it because it's a good way to close. So there's a drunk man is on the street on his knees. A policeman is in patrol and sees him on his knees underneath a lamplight. And he asks, what are you doing? He says, well, I lost my wallet. And the policeman says, okay, I'll help you look for it. So they keep looking for 10 minutes under that lamplight, and then the policeman says, oh, I don't see it. Where did you lose it? And the drunk man says, well, I lost it over there. So why are we looking over here? And then the drunk man said, because the light is so much better here, right? And that is actually what many architects do, is if they have a lot of work, a lot of concerns to address, they first look for the ones that they already know how to deal with, because the light is so much better. And that's fine for designers or for programmers that have to get all of this work out of the way, but an architect cannot afford to do that. The architect has to look for the stuff that he doesn't know how to deal with yet first. And even though it may mean that you make an architectural decision here about a very risky thing that only gets to be implemented at the end of the project, still you need to make that decision. And just keep it in the backlog, it doesn't matter. The next step, of course, is just in time. So only build it when you know that you're going to need it and it's going to affect the economic reality of your solution.
So there are some other questions. Eltjo, are you doing office hours?
I'm not, no.
Okay, well.
But there is a
then-
break now. So.
Yeah, so we've got a break now, there's lunchtime, there's this evening, so buttonhole him later, and thank you very much.
You're welcome.